Welcome to the Soda Podcast, and welcome to Season 1 of the series In Conversation With. Just like good data helps the world go around, so do good conversations. Your host is Maarten and Ramón, CEO and founder of Soda Data. In this series, Maarten will be in conversation with practitioners, technologists, and changemakers who all share a passion in making meaningful connections and rethinking traditional practices. They'll be talking about data, what makes their world go around, and sharing their thoughts, perspective, and ideas that we think will inspire you to be a part of the conversation and be a part of the change. Without further ado, here's your host, Maarten and Ramón.
Hi everyone, I'm Maarten. I'm the CEO of Soda Data, and in this podcast series is called In Conversation With. And today I'm in conversation with Ramón Medrano. Ramón is a site reliability engineer at Google. He started there back in 2011 as an intern and then moved over into a technical lead role, later an engineering manager, and now he holds responsibility for privacy, safety, and security teams. Ramón, welcome. Let's get the conversation started. Could you introduce yourself a little bit, but also your background and what you do on a day-to-day at Google?
Thank you for the introduction, Maarten. So I'm original from Spain, as my name and my accent suggests, right? So prior to Google, I was working at CERN, the physics department. The physics experiments that is in Geneva and France, and I was doing data management for the accelerator for the Atlas experiment. So we were doing the acquisition of the data from the detectors and management, like aggregation and analysis. So we did all these Higgs boson discovery at the time, like 10 years ago, and then I moved to Google, where I'm in the part of the identity team. So we manage all the data for the authentication of the user. So anything that has to do with a user account, authentication of like your password stuff, but second factors, some authorization we do, right? And we manage all the accounts from consumers to enterprise, some part of the cloud authentication as well. So it's pretty data intensive, we could say, not as all the products, but the thing with authentication is like if we are down, like the whole company or most of it is as well down for all the customers, right? So it's some sort of a good challenge, right? How a day-to-day looks in my role as an SRE for this team is basically we need to make sure that the services are up and running, right? But then there is as well an aspect of security and trust from the customers, right? Because we need to prevent, for example, that user accounts they are hijacked by different actors that they always want to hijack in your Google account for like sending spam or doing whatever, right? And as well, we need to make sure that the services they are fast and secure for the rest of the company, because the authentication is whatever happens at the beginning, right? So if that goes wrong or slow, then the rest of the flow is just doomed.
Awesome. Well, it's great to have you here. So thanks for being here. And you're dialing in from Zurich, if I'm not mistaken. And
yep.
I also always love to ask my guests, like, tell us something about the city Zurich, something you'd love to do, or something that attracts you to the city.
So it's a pretty multinational city for being small. So we have like 400,000 people around us, and for the agglomeration, right? So it's not like a huge city. The nice thing is like a tech hub for the center of Europe, but there's not only Google. There are many other companies. So finding people with the same interests and so on, I think that's nice. And then for my daughters, for example, something that they like very much is going to the mountains, and we have that like an hour by car from the city. And that's pretty cool, because in summer you can go with the bike. I do like a descent, so I go with the bike just a bit off the hill and then go down, and then in winter you can just ski, which is I think it's fantastic. And I come from Spain, where we don't have that much, at least in my place, that is the north. So we have the sea, but not like a lot of of these class of activities. So we enjoy that very, very much.
Awesome. And today's conversation is all about site reliability engineering. So let me abbreviate that for the rest of the conversation to SRE. I think SRE is being originated or created at Google, and we definitely today want to learn a bit more about that. But more importantly, we also want to learn how SRE kind of applies to data. There is a lot of influence from software engineering coming into the data and data management space today. And principles and practices like SRE is definitely one of those. So you're part of Jennifer Petoff's team, if I hope I pronounced it correctly. She put you forward to be on this podcast today as she wrote the book, Site Reliability Engineering, How Google Runs Production Systems. So this book explains how SRE, in essence, it builds, deploys, monitors, and maintains, or how Google builds, monitors, deploys, and maintains some of the largest kind of distributed systems in the world. Could you give our audience, maybe to get started, a kind of for dummies explanation or beginner's introduction to SRE?
So SRE, I think the name, it comes from like a few years ago in 2006 or something, like this VP that we have for production, that is Ben Traynor, said that we need to have like software engineers running production, right? So what a software engineer would do when you run production, instead of doing operations by hand, you would just write software for doing it for you. So that's the origin. Site comes because Google had a single site at the time, right? So we were the engineers that doing reliability for our site. So I think now the acronym has lost a bit more of the meaning, because we have many products. There's like tons of services and so on, right? But it stands. I think if I say DevOps, people will be more familiar with the role, right? So DevOps, you see that is like a set of principles of like whenever we have in the past developers, there is operators for services. So we want to bridge that gap, right? And have automation and infrastructure as code and all that stuff. So that philosophy is something that is the origin of SRE at the end of the day, and it's a philosophy that we use, right? So I always want to say that the DevOps is like the class that we have, and SRE inherits from that. So it's an implementation of that interface, if you want to. So we bring all the DevOps principles into the table. But one thing that we use a lot is SLOs. So they are service level objectives. So it's something that we define for a service. It's like how is the service level, so how we describe the service performance, right? And then we set an objectives for that. And then all the automation, prioritization of projects and so on goes along those lines. Right? And then we are let me think how to say, like the owners of productions in some way. So we can contribute whenever we see fit for the reliability of the product. Be it automation, that is something that is very known by people, but we can do features for a service, right? That if that makes the service or the product perform better or be more reliable, is something that is in our hands all the time.
Awesome. That makes total sense. What would be kind of your favorite real life story use case that kind of really explains kind of why you need SRE? Do you have one in mind?
So, well, I have one outage that we had like a few years ago that was, this is kind of old. It's like from 2015, I think, right? But it was, I think, reflects well two things. That is why we need SRE, right? Or what SRE does in practice, and why data is quite a challenge for SRE teams like a Google, that we are like, I don't know, 3,000-4,000 people, right? And it's like in the authentication database, we have a database that has primary data. So it's like a table with the username that you have, some identifiers, the salted hash of your password, some small metadata, right? And that we use that for authenticating you. So whenever you go to accounts.google.com or whatever, and you need a cookie, for example, to access Gmail or whatever, we will just check that database, right? And that database has a schema, and there was a change in the schema at some point, right? So there was a bad job that was like changing that schema to add some, I think it was modifying or adding a field, right? And then it was okay, but there's a bad job that will run, and we'll set up like the new field, and we'll set a default value for the accounts that don't set it, right? And at some point, right, the default value was incompatible with some particular kind of use case that we have around, right? And that didn't materialize until very much like 3-4 months after the fact, after the modification of the database, right? So SRE could do, like, for example, the validation of this, could do, like, for example, the progressive rollout of the change. So, for example, would do like testing that the new schema will work with the binaries that are running on top of it, testing that the sufficient capacity in the database, for example, to hold all the new data they want to have, testing that the queries, they are optimal, so it's not going to take down the database because you want to join two tables in some particular way that is very expensive, right? And then on the other hand, data is hard, right? Because this particular outage, it was not affecting the availability of the service until much later down the road, right? There are many more other corner cases and stories about how this can work, right? So validating or like approving this change in the sense of like this is safe for production, right, was something that was not trivial and that we didn't saw at the time actually, and then we got a corresponding outage in exchange.
Yes, I cannot even fathom or imagine then what the downstream impact of all of that was, but it probably got a bit messy and required quite some manual efforts to kind of fix and go back to a regular normal state.
Yeah, so I remember that it was paged in the morning, like at 7 a.m. Like I was at home, and it's like, whenever you are operating a service for some time, when you get a page, you know that, well, this is okay. And some other pages, when you see them, is like, oh crap, right? This was one of those, right? Because, right. Yeah, as you see, like, I don't know how many million people affected or whatever was it. And then the problem is that the triaging was not clear how to do it, right? Because when you are speaking about an interactive service, like an RPC server, right, it's something that is synchronous in the sense that you can say, like, well, this service is calling this front end, right? Then there is a series of backend. Here is where the failure happens. And then you can see, for example, an stack trace or whatever it is, right? Whenever you have something like that a field that has a default value that is not well processed, you have two problems. That is, usually in the stack trace, what you are going to see, for example, or in your distributed tracing is like you call the database and the database returned the data, right? And it's like, okay, it's not the database because it's returning the data that you want, right? The problem is that the data you're storing there is not what the application is handling. And then another thing, and it's what was happening in that case, like not all the accounts were affected, only a small subset. So you need to find like a needle in a haystack in the sense of like, okay, out of these billions of accounts, right, there are only a bunch of them affected, right? And that was, at the time, was manual for us to find. And then we need to have like all sorts of like people related to the system to help us like understand what were, changes that they were in flight, latest schema modifications and so on. But this was like 3-4 months old, so we were reviewing like in reverse timeline, right? Mm-hmm. So yeah, that was hard.
It's a very interesting example. So I would love to take it to kind of the role of an SRE, site reliability engineer, and kind of what is their background, like how technical, for example, are they? But also, where do they kind of organize or kind of report into? How is that structured? Maybe at Google, but if you have a perspective of how that is outside of Google, that would be fantastic too. So that would be helpful to dive into. Maybe even how are they evaluated, SREs? Are there certain metrics or systems to evaluate how good or performant an SRE is? Those would all be areas I think would be very, very interesting to dive into.
So SREs, we are software engineers at the end of the day. Like they are at Google, we have like two variants of it. So we have software engineers for SRE and systems engineers for SRE. I'm a system engineer, right? The difference is like the what we are looking for is people that they have like hands-on experience in the intersection of like writing software and running systems. So it's not like a perfect balance that you need to find. There is people that is more skewed towards systems, or the people that is more skewed towards software, right? But the thing is like you need to be comfortable writing software and understanding how a network stack, for example, works, or how processes or file systems works in a system, right? Then how all of this is organized, right? At Google, I think it's the only big company I have seen that is organized in the sense like SRE is its own organization. So we have an org that is SRE, so we have like a VP for SRE and so on and so forth. And then there is another hierarchy for like the developers, right? We find this working well in the sense of like our commitments for a system is for the system itself, right? In the sense of like when we take over, we onboard in our team like whatever product, whatever service, right? Our role is to say like, well, we are going to bring this service to the reliability that the product needs for the business definition, right? If it's whatever it is, a chat app, or if it's like a new thing that we have launched for video, whatever it is, like the product managers will say like how much reliability they need. Obviously, they are going to need a lot, right, at the beginning, but then there is a conversation between like developers that they want to ship very fast, SRE, which the incentive we have is not to change production at the end of the day for stability, right? And then you have the product managers that they understand costs, for example, or they understand what the customers want. And then you can say, like, okay, if you want 15 nines, you are going to need to hire 150 SREs for this, right? And then they're going to say, okay, perhaps no, right? And then there's a balance of like finding like a trade-off where you say, like, okay, like, I don't know, 4.5 nines for this service is going to be fine. We are going to need to staff this team this way and so on. And then we start doing projects in partnership with the developers. Right, and there is a point in time that the service is stable enough, right? It's meeting the SLOs that we have set for it for the customers, and at that point, the service in principle is done, right? We could just say like, look, we are offering the service. You just take care of it. You can be the devs, like the engineers will be on call for it. So SRE will just go and move to something else, no? Thus, in theory, there are many services that they are critical enough that will, in practice, always have SRE support, right? Other companies that do this differently. I know that, for example, in Meta, they have the concept of a production engineer, which is the same as an SRE, right? But they are part of the developer team. So a developer team will have X software engineers and Y production engineers, and they will balance this depending on the needs they have over time, right? I've seen this model as well. Both works depend how you have your company organized, right? And then there is the other model that I saw, particularly at CERN, for example. We had DevOps engineers, right? That they would be doing like some general like DevOps stuff for the whole department, right? So it could be like an engagement for the whole system, not for parts of it, like we do at Google, right? And then for the evaluation, that's I think that goes or is a product of how you organize your org. For example, at Google, we have like a complete separate job description, a job ladder. So you'll have like the role for a systems engineer SRE, and you have all the levels, requirements, and there is all this process that the company does twice a year, right? For saying like, well, this is your expectations, this is what you did, this is how it matched, this is like, all the scoring and all that stuff that goes, right? But at the end of the day, it goes into like the projects that you are able to do, right? The change you are able to like inflict in the system, how effective you are doing on call and operation duties, right? And the scope of your work, right?
That makes a lot of sense. What kind of the question it pops up in my mind is also like, how is Google different to other companies in certain ways? And when thinking about it, I think Google is very much known for like a lot of different products and services, of course, but one of them that I was thinking about is all things related to kind of document management and document storage, which is, I could call it unstructured data. Mm-hmm. Whereas I think other companies might have a lot less of unstructured data and more structured data. Would that be, I guess Google has all of it, but for some other companies might have a bit more or less of one or the other. Would that be a valid statement? And would there be other differences like between Google and typical other companies or organizations?
I think it depends. I think it's a pendulum that swings. Depends on where you are, right? You find yourself like a few years ago, for example, when I joined the company, everything was no SQL kind of unstructured data and so on, because it's very easy for this concept of scalability. That is, you will have one global system that will scale ad infinitum, right, and will be very reliable, right? And that was possible when we had, for example, use cases that they were highly dominated by consumer workloads, right? So when you have consumer workloads, for example, the availability that you have, and this is not to diminish anything, but the consumers do not expect to have 4 nines of their own account forever, right? Permanently. So they, for example, sleep and they don't use their phones and all that stuff, right? And then you can afford to build these kind of systems. And having unstructured data with no strong schemas and so on helps you like scaling these systems up, right? Then there is this rise of cloud computing and companies are moving their workloads there and so on and so forth, right? So you are starting to see more and more workloads that they are dominated by, let's say, robots, right? So you have virtual machines that they are running workloads that you don't know and they are calling APIs. You will have things like containers, products built on top of your products that they have their own behavior, and then you have all the compounding effect that smooths out all these availability requirements. Right? So you start to have systems that they are available all the time, right, and have a lot of high performance and so on, right? So building these kind of global systems that they have singular instance, right, it starts being a challenge for reliability, right? And that's where the pendulum, for example, swings back to the other side, which is like, well, perhaps we can just not have, for example, totally global systems. We can have to have like different instances per, I don't know, per cloud region or per continent or whatever it is. So they are differentiated. And then having a better notion of schemas, for example, helps you offering better services for their customers, right? Because you can have like APIs that they are richer, that they can understand better, right? And they are easier to use, right? Because if you offer like, look, here's an HTTP endpoint and you will have some JSON at the end of the day, right? That's not a great experience, I would say, right? So depends what you're doing, right? I think now we are seeing a mixture of all these classes of databases.
Makes sense. I think as I was preparing for this podcast, and also as I also mentioned, I think in the beginning of it, that there's a lot of these principles and practices becoming more commonplace into kind of data management space. So a lot of concepts or kind of best practices in software engineering, and I think it goes far. It starts kind of from everything as code, so to version controlling in data, and now it's also extending into like how do we operate teams being on call, taking responsibility for the reliability of systems, for the quality. So there's a lot of change and kind of influx of new ideas happening. And I was just reading through the book, and as we prepared for this conversation, there are 4 topics really that we wanted to dive a bit deeper into, and also see if there will be differences between such a kind of topic in the infrastructure reliability versus data reliability space. And if I recall correctly, the 4 key topics that we want to dive into were, on the one hand, so the SLOs, service level objectives, which we've already talked about. The concept of lineage and traceability, I think in the context of debugging, but also debuggability as a topic. What are some of the tools, things we need to properly do that, and then how to operate as a team. So I propose we just take one by one. We dive into the concepts, have a discussion around them. What are some, for example, best practices? What are some things Google are doing? And maybe what are some learnings or things that could be applied in maybe other industries or maybe also less data intensive companies. So let's maybe start off with service level objectives. Would you mind giving the audience a bit of a primer? You mentioned earlier, so it consists out of indicators to measure, I guess, the reliability and the health of a system. But could you give the audience a bit of a primer on the concept of SLOs?
So yes, so SLO is something that we as SREs, like, since we are doing that all day, we have like, this bias of like everyone knows it, and I think it's a good thing to do. So the first thing that you need to do to define an SLO is define an SLI, that is service level indicator, which is a metric, right, that describes your system in some particular way that you are interested into. the classical thing to do with services that they are transactional, for example, like an RPC server or a database, right, is saying like all the requests that I send, how many of them they are successful. So the proportion of requests that they are successful. You can make like something as simple as that, or make it more complex. Like for example, the proportion of requests that I sent to the database that they are responded with a 200 in less than 300 milliseconds, right? Or more properties, right? But at the end of the day, it's a number that tells you like where your system is at, right? Then you have the SLO. The SLO is a service level objective, which is an objective for the SLI that we just defined, right? So you want to have the system in such a way that you say, my system is available enough if the SLI is always over, 90%, right? So I want to have all the requests that they are answered by the system in less than 300 milliseconds, over 90% of the time, like being successful, right? And then you have an SLA that I think is that's something that people is more familiar with. The SLA is the service level agreement. Yeah, the service level agreement is at the end of the day is a contract. It's a contract with your customer, right? That you say like, look, we have this contract that says like this SLI is going to be over this threshold all the time, or 99% all the time, right? And if this is not happening for some reason, an outage or whatever it is, we give you in exchange whatever. Like some cloud providers give like cloud credits so you can have discount, right? Others will give you back money, whatever it is, right? Depends of the service you are providing. It might look differently, right? This is the classic example for transactional services, like an API endpoint, right? That's very, very typical.
Very good. So you could apply this concept quite easily to a data flow. Let's say we have a company that there's an analyst within a finance team, and they want or need data by a certain point in time in the morning, and they needed to have it completely available, especially around a certain set of columns, because they may be important for regulatory reporting. Who knows? So you could apply this concept also to this flow, saying, well, in order for us to achieve it, the data needs to arrive at least an hour earlier in our analytical platform. And then we have about half an hour, 45 minutes to do data transformation and preparation. So that's ready. So it's nicely on time for our end consumer. And the contract, the agreement would really be with the end consumer, with that analyst within the organization, saying, hey, we're going to make sure that that data is there. We agree or commit to it. Because it's internal, maybe it's a bit hard to work with credits. But that could be maybe an internal example of setting up SLOs and SLIs. Would that be a good one, or am I looking at different in the wrong way?
No, I think that's right. For example, in your example, the SLI could be the number of days that the data got to the data analyst or whatever whoever needed on time for them to use it, right? And then your SLO would be, we want this to be 29 days out of 30 every month. Right, because 100% is always better, unless there is some regulatory kind of thing and so on. I'd recommend not to aim for 100%, right? Because it's just super expensive. So unless you have to do it for some particular reason, let's just say 29 out of 30, right? And then for internal stuff, it's rare that you need an SLA, right? Because you don't need to tell the analyst, I give you 2 times the data of tomorrow, whatever. It's just an SLO, which is an indicator of like what is the target of quality for the system. The thing with data is that the SLIs, they can be much more complex than with traditional transactional systems, right? If you think about data, there is all sorts of other dimensions, right? Because you have, for example, let me use an example that I have at work, that is the hijacking. So at the beginning of the podcast, we were speaking about like our systems need to protect users from their accounts to get hijacked. That's happening all the time, right? It's like there's some spammers and people that they want to steal your account, right? And we have systems that they will detect the risk of like someone trying to like log into an account, right? We have signals that tell us, like, for example, you are an American citizen logging in from your own town from a device that has an IP that we already saw, that has very low risk. Now, the same login in an empty browser in a device coming from an IP from, from South Africa, that's a completely different story, right? So the this allows us, for example, to ask you for a second factor or do some whatever it is. The thing is that to determine these risks, there is a lot of data that we need to process to have the database that will inform how the risk level of login is, right? And there you are going to have, like, for example, the freshness of the data. That's a service level indicator for the data. It's like, when was this data last generated, right? It's because if it's very old, perhaps it's irrelevant. Right, so you might have an SLI of saying, like, the data that we are using for these queries needs to be fresher than 24 hours. Can't be older than that, right? You have in data other things that are, for example, the retention, right? Not only for regulatory reasons, but yourself in your company might just not want to have data from customers that is older than 18 months, as an example, right? For logs or whatever it is, right? Because you don't want to retain that, right? So you might have to have an SLO that is the data will never be stored more than X, right? And then you have derived data, right? It's like, so we have a database in here that is just a dump of, a batch job that is processing data sources from many places, right? Like if you have a data warehouse or a data lake, this is very common, this ETL kind of processing, right? You might want to have indicators of, like, the data that you are consuming is correct enough or has a level of quality that is good enough, right? And then you're starting to unpack it because it's just recursive. You might not want to generate data with data that is not good enough. And then if there is a series of pipeline, it just goes bananas. It's just crazy.
And did you at Google have, is there some tooling available for very easily setting up, for example, SLOs or SLIs on data specifically?
No, I know. So perhaps we need to look into it more, right? But my team at least, we are looking into data with the traditional tooling, right? And what we're doing is, like, for example, batch jobs that they are processing data, they will export metrics of, like, this is the data I got, this is the success ratio, and so on and so forth. So we can say, well, like, extract from there the SLIs, right? Once you have the SLIs, though, then that's the hard part, right? Because then if you have an SLI, then you are going to have a number, right? And your SLO, if it's over it, then you're good, right? The problem is arriving to that SLI.
The problem is, could you elaborate on that a little bit?
Because you need to, so the SLI at the end of the day is a summary of all the properties you want your system, be it a data or an RPC server or whatever it is, or both, right, to fulfill, right? So if you have an SLI that is freshness, right, that's easy. You can say, like, export a metric of, like, the last time stamp for the data modification, right? And that's it. And you will see how it goes up, right? Until it's generated again. And it's like this kind of sawtooth kind of thing. And then your SLO is going to be a line on top. If it crosses, you are not meeting it, right? If it's something like data quality, for example, you need to define that. What is data quality for your thing? For example, in the hijacking database, you might want to have an SLI that tells you the data quality as the number of signals that you can collect for assigning. So if a user is signing in, right, and then you can elaborate or calculate the risk with, like, IP addresses, with other metadata and so on, you might want to select, this is a high quality data because I can collect data from many sources, so it's rich. If there is a sign in from a new account or whatever and you know nothing, right, your data quality is not high, right? So you really don't know if the login is risky or not because the signals that you are getting, they are not good enough, right?
Yeah, you have a lot less data to make a decision ultimately in that scenario, and that's indeed a part of quality as well as the availability of all of the information that you need to make an accurate estimation or an accurate outcome.
Yes, for data quality, one example that I think is easier to understand and easier to grasp is a search engine. So imagine Google search, right? When you search for a topic, you are going to see a lot of features in the search engine result, right? You're going to see the results, there is some ads, there is some boxes in the right that tells you more. Like if you look for a movie, it's going to show you the leading role actors, the producers, all that stuff, right? So when you're conducting that search, right, there may be some systems that they are unavailable or that they don't have data, right? You might want to present a result to the user, right? And some of the things may be missing. right? So the SLI for that search, for example, the data quality will not be 100%, will be 60 or 70, right? If you keep collecting that all over time, you're going to see how your system is providing data to the customers a certain quality, right?
That makes a lot of sense. Very cool. Can we move into kind of lineage as a topic, lineage and tracing of problems? Maybe I'll give a quick, as a starting point, a quick summary as to how I personally have, like, what my experiences with lineages are and how I see it, and we can start from there. So how I understand and see data lineage, it is ultimately about how data sets that people use or data, how they're connected to the broader ecosystem, whether that's the jobs that produce that data, for example, that is one, or whether it's about the quality controls that are set on your data sets, or what is the kind of the DAG of information. Could be one view. How long your queries take, for example, performance kind of related view could be another form of data lineage. But also maybe seeing who owns what data in organization and drilling down into, for example, how many published data sets an organization has. So lineage is quite a broad topic, but it's very often used in the context of root cause analysis, especially by technical users who, for example, are responsible for the data transformation pipelines. So I see it as one of the tools, but it also can be a tool for broader understanding of really what's going on and about slicing and dicing the information at hand to understand where did the problem actually originated and what is the downstream impact. Is that similar to how you see data lineage and this notion of traceability, or do you have a different perspective on it?
No, I think it's all of the above. If you think about traceability, right, I think people that is listening to us and run some set of microservices and so on, they will be familiar with, like, whenever a microservices fails, right, the whole mesh of things that they are collaborating, like they have problems, and then you just trace and then you see who is calling what and so on, right? There are things like OpenTelemetry and all that stuff that help you. With data, right, it's harder because it's not synchronous in the sense you can just take a snapshot of the system doing your RPC at that moment, right? Because data is generated at different moments in time, right? And it evolves. So a data store is not moving in lockstep all the records that you have. Like you modify some, you add some, you delete some, like some are static, right? So it's like a more living kind of thing, right? So for the traceability, there is, for example, something very easy to understand is when you have derived data. So you have a data store, right? Then you have some batch jobs that they are processing it and dump it like a summary in some place. And then there comes another one that takes these dumps, does another processing, puts them into some data store, right? And then you query that, or then you generate other secondary data, right? Doing traceability of that is very hard, because think if the first batch job has a small bug or there is some data missing or whatever, right? And the dump that it generates is incomplete, right? Then there comes the second batch job, reads that, and it's just not processing some data that should be in there, but you don't know that it's there, right? And then there is a series of things happening, right? And at the end of the day, you have a compounding effect, right? That the end product might be nonsensical, right? And then is when you see the outage in your signing product or whatever is what you are doing, right? And then you see like, but this service is okay. It's querying the database finally, right? Why the data is garbled, right? And then it's who generated that? And then you start unpacking that. And 3 hours into the outage, right, you say like, but why? Right? And it's just a small batch job processing something down the road, right? So I think it's very nice to have a concept of data lineage that you can say like this data comes from this series of steps that happens to generate it, right? So you could at least perhaps can be like a culprit analysis that tells you this one was not great, right? But at least you could see what happens, right? To bring your data to usage, right? And then there's all the governance stuff that you mentioned that I think is as well very interesting, because then if you have a big company and so on, all these processes will be owned by different teams, right? And we know that we end up shipping our org chart at the end of the day for, the Conway law. And the problem is that crossing these boundaries at some point can be hard, right? Because then you're going to start having APIs that they are designed or developed with different styles and so on and so forth. So it can be hard. We were mentioning before the retention, right? That's the example. I think that's classic example for governance, right? So if you delete some records that you have in your original data set because you don't want to keep them more than 18 months or 16 or whatever it is, right? Then all the derived data needs to catch up within the time frame, right?
Yes, and that lineage becomes an important tool, I guess, on the one hand, for finding the first point in time where the problem occurred, but possibly also for the downstream dependencies, right? In this case, where you say, indeed, it's further propagated, so it's further derived into new data sets. So we need to make sure as part of that data retention that we delete it everywhere, including all downstream processes that generated derived data sets.
Yep.
Are there certain tools or methods that you're currently using at Google for this concept of lineage and traceability? I guess there's definitely some of that within the infrastructure kind of monitoring and observability space, probably also for application monitoring and tracing about pages and their load times, etc. And then maybe for data, also how data is evolving, kind of how the DAGs look like, what are the data sets they produce, maybe what are time SLOs on when they should arrive. Is there some tooling across all of the spectrum available as well?
So we have to, just to be honest, we need to differentiate like for like RPC servers and so on. I think we are far more advanced than with data. So you can trace an RPC mostly everywhere within the company, right? So you have things like if people is familiar with Dapper, for example, there is a paper for that. They can use the open source version is OpenTelemetry, and there are some implementations. But basically, you can see a graph of like where your traffic is flowing and so on. For data, we are using a similar approach that is like annotating data and so on, right? But this is harder, right? Because the problem, I think, is inherently different, right? Because of the data, you will have it at rest, right? So it's not like an RPC is something that is ephemeral at the end of the day, right? And I think propagating labels and so on is easy. You just put it there. Can get expensive if you have many of them, right? But it's something doable. With data, it's harder because how are you going to annotate all this stuff? Are you going to annotate per row, for example, right? Because each of the rows, they are different. They might be created at different time. They maybe have different importance even, right? Are you going to be creating by data store? So I think there's a trade-off there of cost and like resolution that you are going to be having, right? And then the annotation that you are doing, they are data too, right? Which might seems like an obvious thing to do, but you are where do you put them? Are you going to have a secondary system for all the annotations for data? Are you going to annotate in the same system? So if such a system corrupts, why is not going to corrupt the annotations, right? So it's not that trivial, right? So the thing that we are doing, at least in my team, in other parts of the company, because Google is huge, I don't know. I'm sure someone is more advanced than me, but or than my team, right? One thing that we are doing is working on SLO maturity processes, which is like, look, let's start with the principled approach of SRE. That is, let's define a service indicator for this system. In this case, this is data, right? And there has been some properties that we are interested into that are able to tell us that the system is healthy, right? So there are the classic things of like if we run a spanner database, availability of the like spanner database as a service responding to RPCs, but as well there has to be SLIs that tell us about the data quality. One place where we started was from the classic data integrity approach, right? That is, okay, let's assume that the database is an atomic thing. The first thing that we need to do is not to lose it. So let's just do the backups, restores, like be able to bring up a new database with a backup and make sure that it serves. The second step would be like, okay, this data, right? We need to see, for example, what is the resolution of restores that we can do? Can we do like snapshots? Can we do point in time? Like having more elaborate kind of things. So at least this is reactive, right? Because it's like, if we know the data is corrupt, at least we can go back to the place that it was not, right? And then where we are now, I think some people is working on it more, starting to look into that, is managing the schemas in real time, which is like, oh, so you want to write some code for this binary, or you want to write an experiment, or you want to alter the schema, right? How we can validate that change, for example, is going to be correct, right? And how can we see that the service level indicators for the system as is and after the change is going to be correct, right? So there is a lot like data testing. It seems like weird, but it's like what's happening is like let's test the new schema with the old data, see how it goes, or the new binary.
Yep. I think there's an entire world of data testing that I think is still quite nascent and new. So there's, of course, testing has been for many, many years, even decades probably now, since test-driven development. It kind of was a point of no return. I guess everyone is now building tests as they're building software. It's part of the software engineer's workflow, and it's a good practice and everyone knows. However, in data, that is not the case. We see that there's companies, of course, and teams that have started to do some testing. But I do think there's still a lot of work to be done. For example, having test suites that allow you to very easily do like an integration type test, where you have new analytics codes, so new ways of transforming your data that you're publishing or pushing to production. Like, how can you make sure that that indeed doesn't impact the quality or reliability? So your SLIs at the end of the day. Do you feel the same? Like, is there still a lot of work to be done there?
Yep, 100%. Yes, and it's counterintuitive, right? Because we see like in all these newspapers and so on saying that data is the new oil and all that stuff, right? However, if you look into how systems are working and so on, I think we're more advanced into all the testing, all the infrastructure like testing and so on in like the processing than the data itself as a concept, right? And I say as a concept that I think of data as something that can rest, right? And you have them and you keep it and then you can use it and modify it, right? And it's at the same time that is a big asset for companies, right? Like there are certain companies that they leave out of the data that they have, right? What they are doing for their customers is they are transforming it, they are mining it, is whatever they are doing as their business. Without that data, right, they would be out of the business. So it's a huge risk for companies not to be really structured and really rigorous with what they are doing with their own data.
Mm-hmm. Makes sense. I think from testing, we could probably go into debuggability quite easily. I think tests definitely help create observability, help create test results, give information about what's going on in real time. How do you kind of see the topic of debuggability within the SRE framework? And are there any specific highlights you have around it that you wanted to share with the audience?
So you just mentioned observability, right? I think that's the key word, right? Because the observability at the end of the day is a property of system that allows you to see what is happening, right? Without having to know how the system works, right? Because I think that's the key, right? If you already know how the system works, right? Whenever there is an outcome that is not what you expected, you know where to go and look, right? Which, like RPC services, microservices, and so on, I think that's the case. With data, it's not. Because with data, you might know an abstraction of the data that is the schema, but you don't know the data that you have in that moment, right? And I think debuggability for data, that's the bridge that we have to cross, right? It's giving me observability of what the actual data is, right? And if you have a database with accounts, for example, that we have billions of them, I'm not going to scan through them or run SQL queries for finding outliers, right? So we need a system that is telling us, look, I can cross, that would be fantastic, saying like, this service that you have is failing RPCs for this subset of accounts, or accounts that they have in field X, Y, and Z, this value, right? that's fantastic. That if I could have that, right, in that outage that we were speaking before, right, I could have solved that in like 5 minutes instead of like a few hours, right? So that's the observability we need to have.
That makes total sense. And you in the beginning also mentioned the example where ultimately there was a subset of the data that had the default values, which were then not accepted by a downstream service, or creates like a corner case scenario. And I think to go back to like debuggability as well, is that actually at that point in time, the person who is investigating the incident ideally should have kind of a pre-baked view that says, hey, we've looked at kind of the all the areas where we have this unique or where we have this new value, and we compared it to all other records. And these are the segments of data in which we find that you have most failures or defects. So to help already guide the user or guide the SRE in this case to better understand, that will be the potential root cause of this.
Yes, it's the root cause. So I think this is all reactive, but if you apply exactly the same technology or exactly the same approach, you can actually make it proactive, right? If you look at like whoever was changing the schema, say like, look, this is my commit that is going to go into the repo. It's like, okay, fantastic. We're going to do this integration test. So we're going to bring a database for the accounts database or whatever it is what we were doing, right? And it's like we fill it with the data we want. Can be a copy of production data if you can afford it. There are sometimes you cannot because it's just production data or financial data or derived data or whatever. But it can tell you like, look, your change under these conditions, if you have enough sufficient data, right, it's gonna fail, right? And then you can see like, oh, let me change that, right? And then you don't have the outage.
That makes sense. It's always better to prevent. I guess the reason why we're not always there is simply because we don't necessarily have these kind of checks and balances in place today, right? So we have an increased reliance on just leveraging observability to get early warning signs of things that are incorrect. But ideally, I guess you get to a scenario in which as you introduce changes, you have a lot more controls around it so that you prevent a lot of problems from happening anyway.
Yeah. The problem is that it's expensive, though. Like, if you think about the like, say, like, I'm going to turn up a new database on the fly for this integration test and so on. There are certain problems that you are only going to get if you get a database of the same size of or properties than production, right? That can be very expensive because there is this thing that if you don't test in production, you are testing a lie, right? I agree with that. However, you can't always have it. Right, and then if you're gonna like manage with smaller databases and so on, right, you need to assume like how far you can get with that, right? There are some cases that you are gonna be limited, perhaps by scale. If you are gonna, for example, find a performance regression, you are only gonna find it in production. This is why moving into production, you need to do rollouts in a slower way instead of like changing the schema like in one go. It's like change for 1%, 10, and so on.
A gradual rollout to your user base. That makes sense. You're actually testing it as part of that workflow. You're testing it on a small amount of people in the end. So to limit the blast radius, I guess.
Yeah, it's a very common practice for features, for example. So you would like roll out your feature code and it's just not used. And then there is a flag that you can push to your servers. And they're like, look, for this fraction of traffic, start calling it and so on. I think with data, we could do it. We have to add support into the databases for it to be easier to use, right? Because right now, if you want to do that, and you use like a pre-made software, like you say, like for example, I use MySQL or whatever it is, right? Which is very common and I recommend. But if you want to manage that, right, you really have to do weird things with schemas and things that they are very time consuming. So that would be nice to have in databases, saying like, look, this is a schema that I want to roll out. Just do it for me. Like, I don't know, a system, a service, like some stuff that will test that into your test database, and then moving into production will be do it slowly.
That will indeed be super helpful. If we move to the topic of like working as a team, so we've talked about it a little bit earlier, in which the SRE is either part of the engineering team of a new product or service that you're building and launching. They can also be kind of more of a central competency center, I guess, who is involved in the same workflow, but then more hands-over information training, but not necessarily full-time part of that team. Would that be kind of an accurate summary of our discussion thus far? And do you have any other kind of pointers around what it means for an SRE really to work as a team?
So as a team, right, we share the service sets, the principles, the job ladder, and so on. But one thing that we share that other teams across the company or in other places don't is the on-call rotation, right? So we are going to be supporting the services that they are in production, but production changes all the time, right? So whenever I get on call, I'm going to get another instance of production that the last time I was, right? So that's something that binds people together well, right? Because then you have to hand off, like how the changes were going, what is the outages that happens, and so on, right? So that's nice. Otherwise, if you remove that, we are an engineering team, like a software engineering team that our features are reliability, right? So they are. It's a bit unfair to say, but the features that we do, no one sees them, right? Because it's like if you see our work, then we screw it up, right? But the process is basically the same for developing software, like whatever it is. So we will just say like, hey, we need to do this change, and okay, let's put a design doc together to see like how we can do it, what is the impact, discussing the rollouts, and then this code needs to be written, put into production, right? It changes a bit. Like there is at some point in time, you are going to have a system that is getting some changes because there are some releases going on and so on. So the system gets some hysteresis in production, and then you get a bit more outages because it's changing faster than it should. And then you just move towards like, okay, we are a bit reactive now, like, solving these outages, doing the postmortems and so on. And then once you finish those projects, your system is more stable, so you can move back to do other proactive kind of work, right? So it's generally within some limits. So you will never have more than 40-50% of your time in the worst case scenario of like on-call related and postmortems and operations kind of work. So it's always like a bare minimum, half of your time is going to be for proactive projects.
Yep. One of the interesting things I read in the book as well was around the concept of toil and kind of the manual intervention. And that kind of as a metric indicates, how much we're spending on kind of firefighting versus building tooling to become proactive. So there's this balance. And if you're firefighting too much, you're in a situation where you actually should really focus on like not doing any new things, improve the reliability of the system as it is today, until there's again, the amount of toil or manual intervention reduces up to like an acceptable threshold, and only then you can go back into making new things.
That's correct. Yes. So that's what I mean with on-call operations and so on. So there's toil that is our abstraction is like we are going to automate ourselves of the job because there's not going to be toil, right? Okay, that's like a moonshot. In practice, it's not happening. So the system, as I said, like there are systems so that they are products that they become mature, they're in maintenance mode, right? And there is a point in time they say like it's not giving that much toil. It's never zero, but it's almost nothing. There is features that are going in, but not that many. At that point, we detach from that system, right? There are others that you live in this cycle that we were discussing. So there is some more toil because whatever it is, and then you can get, if you don't control this, it's a problem, right? Because you can get a system that is burning teams out because there is so much toil that you can only do the toil, right? It's like a vicious cycle. There's so much toil that you don't have the time to do some project to prevent that toil to happen, right? So in that point in time, what you need to do is prioritize the root cause of those toils, whatever it is, right? And try to fix it. So perhaps you need more staffing to try to do it. Perhaps you need to say like, look, there are some things in the service that we are not going to be fixing right now. We're going to lower the SLO while we like fix the toil or whatever it is, right? So there are some decisions that you need to take with your product and your developer teams, right? To make sure that the service goes back into a healthy state toil-wise, right? And then there is the other failure mode, that is, we remove every single piece of toil in this system, right? But we have it. And it's like, why? You're like just overachieving, right? It's like having an SLO of 5 nines for a system that it would only need 3, right? The impact of that is like you are not having enough risk for the system. You're not having enough velocity. So you are costing more than you need, right? So toil needs to be like within some guardrails. So you are always going to have some. You don't need to have more than X, right? So the managers of the teams need to be measuring this all the time and having metrics to see how the health of the team and the system is going.
That's clear. Is there some target that you set on that? Like how much time should, for example, an SRE be focused on kind of building tools and systems to automate versus kind of being in the weeds firefighting?
Depends. So what we measure is the toil should never be more than 40-50% of the time of the team, right? If it goes up, means that things are unhealthy. So that's my threshold for like, we need to stop here and actually focus on doing some projects to remove the toil is 50%, so it's not even 100, right? And then depends on the system, right? So there are systems that they are less important than others, and I think that's very fair to say. Like there are some systems that they are very important, they are core to the company, and they are very high availability targets, right? Those are the ones that they are going to take more of your attention. So if there is automation to do, you're going to do it for them. If there is going to be, data like lineage projects to do, you are going to likely do them for them because those are the consumers of that data and so on and so forth. And there are others that they are less interesting. So you might have to tolerate a bit more toil in these systems, right? And say like, look, this operation will do it by hand for this class of services. We don't do them often because they release like once a month or whatever it is, right? So it's okay. It's just easier or cheaper to do it by hand than to automate for this class of systems, right? So I think it's a balance that you need to find. It's difficult to say like when, right? You need to know your system and you need to work with your product. You need to understand what is your role in the business at the end of the day, right? Which is a very managerial thing to say, but it's the only way to make this decision. Whether you like managers or not, that's what it is.
Right. So if we conclude, I think we've gone from Google's first site, right, and then the kind of the practice, but then Google, of course, became much bigger, much more complicated with kind of a lot of distributed systems and dependencies and different teams and organizations. So kind of that evolution. And I'm wondering, like, as we went through, we often drew the analogy between how it is in kind of the infrastructure application world and kind of what the differences are in the data, especially for structured data. So would you see kind of an opportunity or a need for kind of more specific practices? For example, we could name them data reliability engineering, kind of as a set of an overarching term for the advancement of kind of or bringing in of these practices into the data space. Would you see an opportunity for that, or do you think that SRE is already properly equipped enough itself to address most of those?
So I think both, and it's not because I don't want to answer to the question. I think that I see an opportunity, especially or more likely for the tooling that we need, or like the technological implementation of that. If you look at the principles of DevOps and SRE, right, I think those are very well suited to data management, right? If we look at like you need to have SLIs and SLOs, you need to have automation, you need to have like infrastructure as code, all this class of stuff. What we were discussing about the toil and so on, like those principles, I think we can apply them very well to data management. It's just the tools that we have, not only internally at Google, but open source stuff, companies that they are offering products as a services and so on, there is an opportunity for adapting all that to data. We just discussed about the defining SLIs, right? And we saw how different they are, right? But the concept behind that is exactly the same.
Now, to round off our conversation, can you tell us a bit more what it is like working at Google? I know it's part of the FANG collective. And they're, of course, famous when it comes to technology worldwide. So what advice would you have for anyone wanting to work at Google?
That's a hard question. Well, I have only worked at Google for all the lists, so this advice only works for the Google. The advice, so I don't know. I must admit that I was very lucky for all the process for me getting into Google and so on, right? But because of many reasons. But what I could tell that I have seen very often is that I have seen students in universities. I have seen people working in other companies like, well, Google is just too big for me, right? And it's not. Like, what you need to have, like, yes, there are interviews, there is all these like blog posts and Twitters and like the conversations of like how interviews go and how it works and so on, right? What I would advise is if you are working in technology, you like it and so on, you will have experience. You will have you will know stuff, like build on that. Right? It's like you are a systems engineer, fantastic. Like be a good one, right? And then when you apply to Google, right, the interviews, they are gonna be working with you on, yes, they want to evaluate your fitness for the company, but they are gonna do from stuff that you know. So you don't need to know every single thing that happens in the work. It's like choose something that is interesting for you. Network engineering, like machine learning, like whatever it is, data management that we were speaking, right? And be good at that, like love it and learn and so on. And then I think it's gonna be easy. And there is no gate entry point, or like you need to come from some place or whatever. Like everyone is welcome at Google. So it's not too big for you. You can apply whenever you want.
So no need to spend dozens of hours on lead code necessarily, is what I'm hearing.
No, I think it's more that's useful for certain class of interviews, right? But it's more of a marathon than spending like a few weeks doing some work. You obviously can do it, to like have more freshness for the interview, whatever, right? But what is interesting is your take on an analysis of problems or stuff like that, rather than all the standard library of Python for when you go to the
Makes sense. And how do you see your role or career evolving?
It's hard because we said at the beginning that I have played many roles. So I have been like an intern, an IC, I have managed teams. Now I am a TL again, right? So I think what has been invariant is that I have been working in systems, right? And that the scope of these systems has been growing. Not in the terms of people that is working on them, which yes, because they are more complex and so on, but in the terms of like the importance of these services for the product. Like if you look at authentication, or even if you look at cloud computing these days, like not even GCP, but all the cloud providers, they're like societal kind of systems, right? Like there is more and more people depending on them, like hospitals, banks, like stuff like that. So I think the role of reliability is gonna only be more important, right? Because if we take down, I don't know, GCP or AWS or whatever, like how many businesses, how many like government agencies, whatever, they cannot work, right? So when you think about that, it's like, oh, so this is not Twitter people speaking about Gmail down anymore. This is actually crap, right? So it's like important. So I think the role of reliability is gonna be moving more towards proactive stuff like risk management kind of thing, data management, like applying more systematic and rigorous kind of processes and methods so we can actually understand the systems better.
No, that makes total sense. There's definitely a GRC component or kind of concern around, or driver, I guess is a better word, around all of the things that we're doing in reliability engineering. So it makes sense that will fall under that broader scope or umbrella. Ramón, thank you. I really enjoyed the conversation today. I think key takeaways or learnings from my end are definitely around kind of what exactly is that role of the site reliability engineer? How does that look like within an organization, within Google specifically? What do they do on a daily basis? How do they work with everyone? But also that SRE is evolving to also include more scope around data, because data is a unique problem. It's a unique asset or component that requires some new tools and thinking to better manage, to make more debuggable, to better kind of become proactive, to handle incidents in that space. So thank you so much for taking the time today. Thank you, and thanks, of course, to all of our listeners for joining in today just as well.
Thank you for the time. I think like the conversation has been really, really good. Thinking about this in out loud actually helps putting ideas together that usually you don't do by yourself. So I think it has been a nice time discussing all these topics.
That was a great conversation. When our peers share, it's an opportunity to listen. Where others have tried, where others have succeeded, we can learn. Oh, for the power of trusted relationships and this data community. Join the journey and get connected. Follow Soda to be the first to know about new conversations as soon as they drop. We'll meet you back here soon at the Soda Podcast.